In this video, we're gonna look at functions defined in tables, by tables and graphs, and try to find the inverses and interpret their meaning. Okay, so let's take a look at example 5. It says a function f of t is given below, showing distance in miles that a car has traveled in t minutes. Find and interpret the inverse of f at 70. So f of, since they're giving us the inverse at 70, this is the input for the inverse. This means it was an output for the original f function. So we're looking at this pair of values where the output for the original function is 70. So we have f of 90 equals 70, and the inverse of 70 is 90. So let's think about it. What is the input for the f? For this is minutes, and the output is miles. Now for the inverse, they switch. The input becomes miles and the output becomes minutes. So how do we interpret this? So in order to cover 70 miles, the car has to go for 90 minutes. Okay, so the in order to cover 70 miles, the car will travel for 90 minutes. Okay, so that's how this works. Okay, so I want you to try this problem by yourself. It's the same table. It says using table below, find and interpret f of 60 and the inverse f of 60. Okay, go ahead and try it. And we're gonna proceed to the next example. So here we have a function defined by a graph, and says a function g of x is given below. Find g of 3 and the inverse g of 3. Okay, so this is the original g, and it says evaluate. So the first question is to find g of 3. So the input is 3, so the x value is 3. What is the output value? So 3 is here, and it looks like the output value for the input will be 1. So when x is 3, the output, the y is 1. Now for the inverse, well, remember that for the inverse, x and y flip. So now this is a y value. So here the y is 3. What's the corresponding x value? Well, the corresponding x seems to be 5. Okay, so that's how you work with graphs of the functions. That's how you evaluate functions and their inverses. Now, if we were to graph the inverse of g, right, just like using the symmetry, well, then this would be the graph of the inverse of g, and I could actually find this value from this graph. Let's see. So when x is, so that's now the x became y and x became and vice versa. It's already done. So I would be looking for 3 on the x-axis, but I would actually pair it with this graph, right? Look up on this graph. So, and that's going to be 5. So yeah, if you have an inverse, then you would do that. But if you don't, you could still use the original function to find the values for the inverse. Now for you, I would like to try, this is, I need to correct this. This is g, the inverse of g at 1. Okay, so it says use the graph to find the inverse of g at 1. And this is, and the estimate, again, this is the inverse of g at 4. All right, go ahead and try it and let me know if you have any problems with that. And I'll see you in the next video. In the next video, we're gonna talk about functions defined by a formula and how to find their inverses.